before I forget, today you're watching this on Thursday, and yesterday, Wednesday, was Søren's birthday, so happy birthday, Søren. And then on Saturday is Henry and Jane's birthday, so happy birthday, Henry, happy birthday, Jane. I want to talk to you about what you should bring to tomorrow's mandatory live Zoom. You're not going to have to print any notes, you're just going to have to get some materials ready. And they're easy materials. I just want you to have a heads up so that you can have them ready. Maybe even once I tell you what they are, maybe you pause the video, pause the Nearpod, and go grab these things and put them near your workstation so they're ready for tomorrow. So we don't slow down tomorrow's lesson by everyone running around to get the materials at that time. You need some Scotch tape. If you don't have Scotch tape, pretty much any kind of tape is going to work. And then scissors, and ideally 2 different color markers. Yeah, that's it. So if you can have those things ready for tomorrow. Oh, one other thing, paper. Although I think paper probably people have next to their workstation anyway. We don't need any fancy paper. Standard 8.5 by 11 is going to work perfectly. And we're going to explore topology, T-O-P-O-L-O-G-Y, together on Friday's lesson as a fun final activity together for our last class for the school year. All right, please consider that this is going to seem extremely challenging until you see how it's done, or unless you figure out some key element to this. But this do now problem is saying you've got a number 102 in some unknown base. It's equivalent to 291 in base 10, and they're asking you to find out what base number is this number in. Is it binary? Is it base 3, base 4, base 5, base 6, base 7, base, obviously not base 10 because it would be the same digits. Maybe it's base 12, dozenal. You try to figure out what base system. If you're using a guess and check approach, go ahead and try that a little bit. You might be successful, but there's a much easier way. So spend a little bit of time thinking about that, but then feel free to hit play if you get stuck or you don't have an idea, and then we'll talk about how this can be done. The key to this is understanding that, for example, the 291 in base 10 is, these are the place values. 10 to the 0, 10 to the first, and 10 to the second. It's 1, 1, 9 tens, and 2 hundreds. So this unknown base has place values. B to the 0, B to the first, and B squared. Well, B to the 0 is 1, no matter what the base number is. It's always the ones place. And so we know we have a 2 in the ones place. We know we have 2 ones. B to the first power is just B. But we don't have any B's. 0 B's is 0. B squared is B squared, and we have 1 B squared. 1 B squared is B squared. So this, another way to write this number algebraically would be B squared plus 0. I'm not going to write that. Plus 2. B squared plus 2. So B squared plus 2 equals 291. And then we can do some algebra like we practiced all year. Subtract 2 from both sides, property of equality. And you get B squared equals 289. And this might not be a perfect square that you have memorized, but you can, even if you don't have it memorized, you can think about some easy perfect squares to check, like 10 squared is 100. So it's got to be, B has to be a number more than 10. 20 squared is 400. So it has to be a number less than 20. It's a number between 10 and 20, non-inclusive. And then there's another trick. If it ends in a 9, you think of what digit, when it's squared, would result in a units digit of 9. I mean, 1 squared is 1, 2 squared is 4, 3 squared is 9, so maybe it's 3, maybe it's 13. So maybe you try 13 times 13, but then you find out that that's 169, so it's not 13. But it could be a number ending in a 3, but it's not in this case. 4 squared is 16, that ends in a 6. 5 squared is 25, that ends in a 5. 6 squared is 36, would give you a units digit of 6. 7 squared is 49. 7 squared. 17 times 17 is 289. So when you take the square root of b squared, you get b. When you take the square root of 289, you get 17. So this is base 17. It's 1, let me replace this with 17 squared. And replace this with 17. It's 1 17 squared, which is 289, and 2 ones, 289 and 291 in base 10. So that's base 17. Now, I hope you're still watching and haven't advanced the slide yet, because I want to tell you something. These problems are challenging. I did that on purpose. And I want you to see where this idea of different base numbers can take you, and how challenging and rigorous these problems can become, yet still solvable if you understand the core ideas about the place values and constructing a model and using algebraic methods and properties to deconstruct an equation. This sort of combines so many things we learned this year. So I'm sure you're using this Nearpod well. I'm going to just tell you that if you see a slide on the Nearpod and you try it on your own and you're not getting anywhere, or you're getting frustrated, don't get frustrated. Just flip ahead to the video, get some ideas, and then do what you can on your own. But you're going to learn a lot if you put the time in on this Nearpod. Oh, one last thing, sorry. It might be overly long, and I'm not requiring you to do any more than 45 minutes. I say 45 because we don't have a live class today. There's no assignment. I'm trusting you to do your best on as many of these Nearpod problems as you can do in 45 minutes. And if you find it interesting and are motivated to sort of like try to up your game even more, you're welcome to do more than that, up to and including the whole thing, but I leave that to you. That's just a personal choice.